The first method of integration that we look at is called the power rule for integration. And we've seen this in class already. And it is used when the integrand can be expressed as a combination of u to some power multiplied by the du for that u. So this is the differential, right? We talked about differentials earlier in the course. And so what we want to do is take a look at the integrand. Everything in here is called the integrand. And if it can be broken up into being a product of some function to a power multiplied by its differential, then we can use the power rule for integration to find the integrand itself. This integrand will then be found by raising u to the power of n plus 1 and dividing the whole thing by n plus 1 and adding the constant of integration. Now this method of integration only works when for all n except when n is equal to -1. So as you can see, if I was to sub a -1 down here, -1 plus 1 would be 0, so there would be division by 0. And that was the exact reason why we have this limitation in the power rule for integration. Now let's take a look at an example. You'll notice here we have the integral of tan x multiplied by secant squared x multiplied by dx. And so this is a combination of a couple of different functions with respect to x. And remember, we are looking for a function to some power and also multiplied by its differential. So we want to think back to our derivatives. And this is going to be very helpful when we are trying to decide which method to use for integration. This one will work if we have a function in here multiplied by its differential, or some multiple of that. So recall that if we let u equal tan x, that will be this part right here. There's our u, and I'm going to do that in red. U, right there. And it's raised to a power, that'll be a 1. And therefore, just not even looking back at this, if I focus on u equal to tan x, the du dx, the derivative of tan x, is equal to secant squared dx. And to take that one step further, where I multiply the dx up on the right-hand side just to get the differential, du equals secant squared x dx. So there is my du. So I do have an integrand that is of the form the integral u to the n du. And actually, let's use my same color scheme. All right, u to the n du. And it fits, right? There isn't anything extra. If there was something more like an x squared in here or some other function of x, then it would not fit. But because it fits, we can now use the general power formula for integration, which means I'll go straight ahead to u to the n plus 1 all over n plus 1 plus the constant of integration. So let me take that now to my answer. I'm going to say that, well, the integral, better integral sign, of tan x secant squared x dx is equal to, let's take our u, that's tan x. We'll raise it to the power of n plus 1 right up here. N is equal to 1, so now it's going to be raised to the power of 2. And we have to put it all over n plus 1, which is 2 plus the constant of integration. This could also be written as 1/2 tan squared x plus c. Here's a second example where we are asked to find the integral of 8x times sine cubed 4x squared times cos 4x squared times dx. Now remember, we want to divide this whole integrand up into a few specific parts. U that's raised to some power and a du. So I have to be starting to think about which function am I going to call u, and it needs to have its differential included in the integrand. The differential is essentially like the derivative but multiplied by dx, so that'll get included with the differential. So let's think about this. Let's write this out. I'm going to say, what about if u is equal to sine 4x squared? Okay, that means n is equal to 3 because sine 4x squared is cubed raised to the power of 3. Then let's get the differential. The derivative of sine 4x squared, we'll just do that first in derivative form. Du dx equals the derivative of sine 4x squared. Well, we must multiply by the derivative of 4x squared, which is 8x. The derivative of the sine function is cosine, and it's the same angle. And so therefore the differential du is equal to 8x cosine 4x squared times dx. All right, so there's 8x cosine 4x squared dx. All of that is our du. Our u is here, and there's our n. So this integrand does take on the form, the integral, get the right color going, the integral u, oh, I got it over here. It does take on this form, u to the n du. That's why I use the color, okay? So I'm going to go straight to my answer. Will be equal to, I must raise u to the n plus 1, which will be sine to the power of 4 times 4x squared all over 4 plus c, also known as 1/4 sine power of 4 4x squared plus c. And that's it. I hope that helps. There are, of course, cases where we may have to get a fraction of du like we've seen before, and then we can get into more of those examples later on. But this is the basic use for the general power formula for integrating.